let's bring it back to basics for our audience.
Sure.
What is mold?
Well, mold is one of these terms that can mean different things. So mold is like sort of that structure of fungus that's growing and infect it, and then it will sort of sporulate, and then release these spores that can then go and infect and grow further. So effectively, mold is like a fungal growth, if that makes sense. When people say mold, it's actually a catch-all term that can refer to a few different things. But effectively, these are species of fungi that are abundant in our environment, and they sort of can grow very rapidly, sporulate and release new spores. And so obviously they can... So that's it. I don't know if that's answered your question, but it's sort of... it's one of those sort of terms that can mean lots of different things, if that makes sense.
Stupid question from me. What is mold the same as a mushroom?
That's a great question. So if you go back right to basics again, so there's sort of in the eukaryotes, there's, as you know, that, so there's sort of bacteria, which are prokaryotes, they're separate, and then you've got plants, animals, and fungi.
Okay.
So they're sort of major kingdoms. And so fungus is a huge kingdom, and it can generate huge amounts of so many species. And so the mushrooms, like fruits, is sort of a fruiting, so that's certain types of funguses will generate things like mushrooms. Other funguses will sporulate, form these like hyphal strands, and then release more and more spores.
Okay. Is that what we're referring to now? When
I think that's what commonly when people say mold, they don't necessarily mean the mushrooms that they eat in the that they get from the supermarket. They're thinking more of the mold that you get growing in your bathroom.
Technically, they're from the same kingdom.
Well, yeah, exactly, yeah. But obviously the fungal... And this is where, I'm not a mycologist. If that, I study fungi, but there's lots I don't know.
Yeah.
The more you study, the more you don't know. And so, but there's this huge variety. And there's people that go mushroom hunting, and it's sort of a huge community of people that are fascinated by fungi.
Yeah.
Sort of medicinal benefits of it and things like that. So absolutely. I think when people are saying mold, they are more meaning that, the unwanted growth in their homes, I think, traditionally.
Yeah. So when we're specifically talking about domestic mold, what kind of molds are we referring to? What are the sort of names? And
so in terms of species and sort of the major genera of funguses that you're getting, so things like Aspergillus, which is primarily what we work on, things like Alternaria, Penicillium, I'll forget, Cladosporium. So when people say mold, they'll actually have a mixture of all of these different funguses present. And that's actually one of the complexities of it, is that when people say they've got mold, that'll actually be a mixture of different species. Most of these molds, and these molds are around us all the time. Probably jumping ahead into one of your other questions, but they're sort of adapted to grow very well in soil. And of course, in the home environment, so they love warm, moist sort of conditions. And so then that's why they're sort of particularly like homes, because homes are particularly warm and moist. So, but also it can vary. So different seasons, different sort of conditions in the house can actually, you could get mold that will look similar, but it's actually perhaps different species, different types of mold.
So you can't determine the type of mold you have just by looking at it?
You can. Okay. You can. So, but more... So there's sort of black mold, is that everyone sort of thinks of?
Yeah, because I'm looking at black mold at the moment.
But that will be a mixture of different funguses. And again, when people say black mold, that can mean a different funguses. This is part of the complexities that people don't really know very well. There's not many studies out there where we go into people's homes and really define what is in the home. It's incredible. I mean, there is some, but it's a really patchy.
Oh my gosh.
Patchy. In fact, I mean, so I should stress, I research in why does fungus cause disease. I'm not an epidemiologist, but I know I collaborate with people that are, and they're trying to set up studies where more going into people's homes to work out what is there and how is that potentially correlating with making people unwell.
And just to anchor the listener, you've got a number of different questions, and you're trying to answer one of them. The first one is, how does mold get into our house? Why are we seeing an increase in the exposure to mold? The second question, which you're involved in, is what are the mechanisms behind disease caused by mold? And then thereafter, I guess, is, okay, well, how do we eradicate it? How do we create healthy environments where we can get to the root cause of why people are being affected?
I think that's a really lovely summary. Yeah, absolutely. So you can't do everything, but obviously the hope is by working together with other people answering those questions, we can understand the whole much more effectively.
Yeah. Let's try and answer that first question, actually.
Sure.
Are we seeing an increase in the amount of mold in homes? Or is this an impossible question to answer?
No. It's, we debate this. It's one of these questions that's very, without data, it's very hard. So people that study home exposure of of things in the home that are pollutant, and they generally don't look for fungi. When you meet people who are, there's a lot of interest in small particle pollution and things like that.
Yeah.
And wood burning stoves and things like that. But actually the particle sizes released are similar to fungal spores. But it's almost like this sort of, the proverb of the elephant, and everyone's looking at different parts of the elephant, and you won't necessarily predict. So there is this sort of challenge of people have generally ignored fungi. And so, yes, almost certainly fungus has always been in our homes. It's just perhaps been ignored. And it's this classic, the question, I guess, is it's impossible to answer, but has it gone up? I suspect it probably has, because I remember when I was growing up, nobody talked about mold in the homes, but it was always there. And I think as sort of central heating has become more, sort of more prevalent, and also home quality perhaps as well. There's the socio, which again I don't work on, but there's clear, like if your housing stock is poor, then you're going to get more risk of getting mold infections and things like that.
With the caveat that we don't have as much data as we'd like to on whether mold exposure or mold prevalence is going up. Let's take the argument that it is going up.
Sure.
How would we explain greater levels of mold in modern houses? The things that come to mind for me are, well, I've got my heating on the whole time. Like I'm not in a cold house,
Absolutely. So again, this is, they love warm and humid environments. And of course, in the winter, you are creating a warm, humid environment, which is perfect conditions for mold to thrive. If you are drying your clothes on radiators in the home without opening the window, which is completely understandable, you're trying to get your clothes dry. That is also boosting up the humidity. So
I've got a baby right now. Me and my wife had a child. She had a child. I was just present. She always likes to remind me of that.
Yes.
15 months ago.
Congratulations.
Thanks. The washing has gone through the roof, and there's only so much our dryer can tolerate. So we are constantly putting stuff on dryers. And it's the middle of the winter as we're recording this right now, so none of the windows are open. I'm kind of worried.
So I think the first thing is, people ask me a lot of these sorts of questions, and don't panic. Oh, I just hit the microphone. Sorry. Is not to panic with these things. We are seeing mold all the time. So you walking out the door, you're seeing mold. And there's so many other factors. Not just in your home, where do you work? What are you exposed to in your work? What kind, so for example, farmers are exposed to much, so your occupation can also have massive implications on all of these things. But there's also things like if you've got housing, if you've got damp as well.
Yeah, damp,
that also can sort of foster that. So it's I guess it's not to panic, it's more to be aware of these factors so that if you have a problem, you try and correct it.
Are there particular building materials that are breeding grounds literally for mold? I'm thinking of cheap wood, plasterboard, certain wallpaper, paints.
Well, there is anti-mold paint you can buy.
Okay.
Anecdotally, I've never tested it, so I can't say if it's effective or not. My research doesn't really study the different materials, but this is not a new thing. So, for example, a colleague of mine, he lives in the countryside, and he was telling, we were chatting the other week, and he was saying he's got this sort of, he's tried all sorts to get rid of, because thatched cottage, that can also. So it's not necessarily just old versus new materials.
Gotcha.
This is just, we live in, and it's not just the UK. Most countries have molds everywhere. There's probably only a few areas in the world where there isn't mold. These spores can go really high into the atmosphere and circulate around the globe, if that makes sense.
Yeah.
So I wouldn't really worry too much about certain materials or not. It's more just about keeping on top of it if you notice it, trying to clean it.
Yeah.
But we don't really know, and I guess this is the crux of your question is, what is a safe level?
Yeah.
Right? We don't know. So this is one of the key questions that we want to try and answer. Me, and not just me, but the community, of if we could understand how and why they do this, and it is almost certainly that some people are more susceptible than others. Why is that? We don't know. Is it that they've got other conditions? Absolutely. If you've got other conditions, that can almost lower your threshold, we think. But we need to do those studies, and that's kind of what my group's trying to understand, is that what is a safe level versus a level that's more concerning and needs addressing. So I think at the moment the advice I would always urge people, which is similar to what people try and common sense, try and just reduce it as much as you can. If you can open windows occasionally, even though you've got a baby, I understand, and you're trying to keep it warm, but trying to keep a breeze through occasionally can be a good thing to do.
Yeah, because we live in a relatively old building, so I think it's already a little bit more exposed to mold than just where the water collects outside and stuff, and the brick itself. There's so many different things that could potentially put us at risk of mold.
Exactly.
And I guess without answering the question of how much is a bad level of mold, how do we even measure mold exposure in a room? So
that's a great that's a great question. So you can buy kits. There's things where you can put a plate and you just sort of put it on your windowsill.
Just a normal dinner plate.
Oh, sorry, I should have said. Sorry, my apologies. Sort of a culture dish plate.
Okay.
Like a plastic dish, and you can do this in the home, and then you literally are just relying on it falling on the plate. That's one way. There are air samplers that you can get as well. It will actively profile the air, because obviously, but again, where you put this in the room, the type of day, the time of year. So for example, I think a lot of there are forecasts and people project sort of the extent of the fungal like when's it most prevalent in the environment, and it's mainly in the spring and the autumn. If you go outside, you get this sort of massive spikes of
spring and the autumn. Really?
Yeah. So that's in terms of the outside exposure.
Okay, sorry.
So in terms of the home, if that makes sense. So that's the other thing you got to remember, that it's also outside. So it's not just in your home. If that, but so it's one of these. There are ways you can measure it, absolutely. Trying to work out, though, what it means to help you is one of the challenges, right? So it's that question of, because we don't know how much can be there. The other challenge, to answer your question actually as well, is that trying to identify them can be quite challenging. There are these
types.
You can normally have to use like a microscope to sort of really screen. Obviously, the most effective thing is if you sequence their DNA.
Okay.
And there are researchers. Again, my team sort of collaborate with these kind of people, but they sort of go in and go to people's homes and try and see. The most effective way is to sequence the sort of, you're swabbing the walls and sequence it.
Okay.
But that's quite a sort of research intensive thing that wouldn't be sort of available to the
general public. Yeah.
But those are the sorts of studies that we need to do to really sort of address your question, really.
So with the plate, that will give you an idea of the different types of mold that you might be exposed to. Again, with the caveat of depends where you put the plate. You're putting by the window. You're putting by the aircon. In the corner.
Exactly.
So with the plate, that will tell you what's there in terms of.
But getting amounts is very. I think
getting amounts is different. So in terms of like these air samplers.
Yes.
In terms of measuring, I don't know, per cubic meter.
Yeah,
like how many spores there are in the
environment. So no, it's fun. I'm only smiling because I was debating this with my team the other week about where's the data that shows how many spores we breathe in.
Yeah,
most of it is sort of it's really patchy, and so we always say that we breathe in thousands of spores a day, but that's very crude estimates, and of course some people could breathe in much more and some people much less. And these are lots of it's from like mathematical modeling and trying to work out in a cubic meter of how many spores there were.
Yeah.
And then they sort of projected. So but you can, it is a fascinating question that you can kind of go down.
So in terms of a range and how we would actually measure that, let's assuming like you're in a completely sterile environment.
Sure.
Are we looking at the number of spores per cubic meter? Is that a good measure?
Yeah, roughly. I mean, again, it's just a really hard thing to accurately measure because, of course, so for example, if you hypothetically think about it, you've got a room, you've got a really dense patch of mold on one side of the room. What's the level of exposure on the other side? So, and obviously, wherever you put the equipment, these are the kinds of questions that we don't really have a great handle on. I guess to answer this question, it's difficult, right? It's really challenging, which is perhaps one of the reasons why there isn't much data out there.
Yeah,
because you need to go into people's homes. You need a lot of buy-in from them. You need to get a lot of different, to get enough sample size. So it's a really challenging question and you'd also need to do it over a long period of time to try and normalize seasonal differences versus what about in the summer? Your great point about, I've got the heating on at the moment because it's the winter at the moment. But in the summer, how does that affect? And of course, when you do the study, it could really alter that.
Yeah.
And so these are the kinds of questions that we need to address. It is unfortunately one of the challenges of working on mold is that you spend a lot of time going, I don't know.
Yeah.
But that's why we need to find out.
Yeah. And so is there any range in a cubic meter that you're like, that's just stupidly high? That is like, I would be worried if I would do something about it myself if there was a way to sample anything that showed a number of spores per meter cube.
So no. I'm not judging the question. It's just generally there is no such. We don't know, and of course, because it could be relative. That's the other challenge, right? So if you said, it's this numbers of spores per cubic meter, for example, then but if you're immunosuppressed, then your risk is way lower.
Yeah.
So. Your risk is
way higher with a lower amount of exposure.
You got what I meant. So that's one of the challenges of really answering this question is that it almost certainly will vary depending on the individual, and also it's not just the amount; it's how much you are. Does that make sense? So what I mean, so it's not just the amount of spores you breathe in on one instance. It's are you breathing it in the same amount tomorrow?
Oh, okay.
What about the day after?
Yeah.
What about the day after that? Does it go up or does it, is that classic? This is one of the challenges of working on, I guess. And also, I should add, people who potentially develop these responses to fungi, there might be other factors going on as well, so that might also be, these things are multifactorial. There's never just one thing. I think fungi are a crucial factor of often be ignored, but pollution is another factor, right? If you're living in a city versus a sort of countryside, you might have differences in mold, but there'll be other factors as well. So it's a really tricky question to untangle. So I'm not being evasive. It's just we generally don't know. And these are the kinds of questions that we really, it would be great, if I was to come back in the future and answer those kinds of questions with research. But that's why it's one of the challenges of the field, which has sort of attracted me to work on this question.
It's fascinating because this is essentially, and what I'm asking you is, in a roundabout way, is how much exposure do I need to, be exposed to in order to there to be ill effects or harm? But then also the additional question is my susceptibility as well, which can determine whether a small amount of exposure is going to lead to harm or I'm actually pretty resilient, and you're going to have to really whack some mold over my my head.
It's funny because when I think we were chatting earlier about people. I didn't my research trajectory, so to speak. I didn't start working on mold. It's something that I became really interested in. I started my research career started in the immune system, and then fell into fungi, if that makes sense, because I thought it was such a fascinating question. And I go to conferences regularly now and present to other scientists, and regularly people come up to me and said, And I've been meaning to deal with that mold patch for ages. I think people think about the home exposure, which is absolutely sensible. But things like composting, right? If you compost a lot and you're in the garden a lot, you will be exposed to a much higher level of these kinds of funguses than you will be otherwise. So if you're doing lots of gardening work, of course you're tilling the soil. Obviously, how the whole concept of composting is that these molds are really good at breaking matter down, right? So it's that thing of everyone obsessed about the home, and rightly so, but where you work. So I remember it's anecdotal, but I remember a colleague of mine told me about one of their colleagues that he sort of developed sort of allergies and asthma over time, and he retired, and they moved the filing cabinet away from the office, and there's this big mold patch that they never realized was there. So it could be that, it needs such a long period of exposure to really drive that as well. So these are really deceptively simple questions to try, but really complicated to actually untangle.
Yeah.
Because it's like, if you're exposed to a high level of spores, but it's just, as you were saying, whack around the head with them, that might not be a massive problem compared to somebody exposed to a low amount, but all the time.
Yeah.
And that there's no way, unfortunately. Well, that's one of the things we're trying to address is, could we actually try and understand this?
Yeah. Let's bring it back to a question you are more like to
sure.
So what size are we talking about with mold?
So it's
How do we
sort of
measure that?
very small, as in you need a microscope to, so for example, so the particulate matter that people really worry about in pollution is the PM 2.5. I don't know if you know much about pollution.
No, tell me about PM.
So pollution that people worry about is like car fumes and all the diesel, etc. Is PM stands for particulate matter, and if it's under 2.5 microns, they're sort of PM 10, which is 10 microns. So the 2.5 microns is what people are more concerned about. Even things like tires. Yeah. Like the rubber on car tires, that actually creates particulate matter that we're all breathing in. Spores depends on the sort of type of spores, but things like aspergillus that we work on, they're right in that 2 to 3 micron range.
Oh, okay.
So you would need a microscope to see that. Some of the spores can be larger. We're talking 40 microns, right? But they're still, so for people who don't talk those kinds of units very often, your cells are tens of microns big. So some of the spores can be larger than the cells that we have, if that makes sense. But some of them will be way smaller.
Wow.
So that's actually a really interesting aspect of the biology of why some spores might be driving different kinds of response just because of their size.
Just from the size, yeah.
Because it will drive different responses as you breathe it in or get it on your skin.
Are there a particular type, like the ones that you mentioned earlier, like penicillinum, aspergillus,
Cladosporium.
Yeah.
There'll be a quiz at the end.
Yeah. Are there particular ones out of those that tend to be smaller, or?
Yeah. So aspergillus is the one that we work on mainly because that's not because the others aren't important. We think they are, but we work on aspergillus because that's one of the most clinically sort of associate, in the clinic of clear sensitization to aspergillus is a key feature. But yeah, so Cladosporium, Penicillium, they're sort of similar sizes, and then Alternaria is a bit larger. But there's other funguses as well that can cause allergy, but those are the major ones that sort of people, that people focus on.
How many are there? I mean, it's a stupid question again. How many are we talking? Hundreds, thousands?
Well, no. So it's one of these things. The more you look, the more you find out, right? But there's sort of a few more species of fungus that are associated with causing allergy. So there's this sort of fungal mix that people will be screened with to see if they're sensitized to fungus. But there's obviously thousands and thousands of other types of fungus. Whether why they're causing allergy and the other ones aren't, that's a great question, right? And that's actually one of the questions that we try to think about. What is it? What makes one of those 4 funguses that you talked about particularly more allergenic than all the other funguses we see?
Let's talk a little bit more about mechanisms. So
sure.
Is it the fact that they're so small and can be readily ingested that make them inherently harmful, i.e. they're triggering the immune system in some way? Or is there some... I'll let you talk through the...
No. It's,
mechanisms.
so this is very much in my wheelhouse, so to speak. So the spores themselves are beautiful and fascinating, so they're these sort of very small molecule, but they can grow incredibly quickly. So within 12 to 24 hours, they can form these long hyphal strands. So they are primed and ready to go. But actually, when we breathe them in, they're kind of coated in this layer that masks a lot of danger signals that would normally activate our immune response. But if they get the chance to grow, then they can go nuts. So we know that the immune system, so this is, again, what I study, we know that cells of the immune system are really good at clearing these, but how our immune systems work in health to clear them without causing any sign of disease, we don't really understand that very well. As in, most people study this sort of really sort of diseased situation, and then when there's a disruption, they're not cleared, then the spores can drive this response. So these are really difficult questions to model, because you're right, they're really small, so they get quite deep into our airways, and so that we think causes most of we have sort of cells in our body called macrophages, and these are sort of they're called macrophage because so they're sort of very good at sort of eating things, and they're kind of constantly maintaining and clearing out surfactant and all the stuff that our lungs produce to help sort of us breathe. Macrophages are in their airway clearing all this surfactant up. We think those are the cells that are really responsible for clearing a lot of these spores. But why they suddenly stop, say, if somebody's sort of getting this development of a response, is that's kind of the switch we're interested in. Is why is it that these cells suddenly stop doing that, along with other cell types coming in, and what is the sort of controls of that? Yeah, how is that regulated?
I didn't realize they stopped, and that was the cause of the issues that we see.
That's our hypothesis, right? So some people would argue that the spores themselves are not driving disease. They are just, say, if you've already got some other condition, the spores will come in and then make it worse.
So it's the immune system that is leading to the symptoms of disease?
Pretty much, yeah.
So spore infection itself.
Well, exactly, yeah. So what we think is going on, and again, proving this in humans is challenging, but with models that we have in the lab and things, we think that absolutely, we think mostly the spores are cleared with us quite effectively with the immune system, fairly silently, and there's something happens that that triggers other cell types to come in and make that immune response worse, and that underpins a lot of the disease. So like asthma and lots of these allergy conditions, it's all immune cell mediated.
Yeah.
And it's inappropriate, right? So you don't want to be responding to fungus.
Totally, yeah.
You don't want to, and another sort of classic asthma-related allergen is house dust mite. So your immune system reacting to that is completely unhelpful. But why it triggers that in the first place, considering we're all exposed to it, is one of those sort of big questions that we're trying to answer. And of course, the other thing is the fungus is doing something as well. So it's not just the host, right? So what we found is that the fungus, even though it's being cleared, it's still growing ever so slightly as we breathe it in, which is this weird thought, isn't it? So it's actually exposing factors that can drive this response. So the fungus is having a role to play here as well, if that makes sense.
I'm in front of some mold.
Yeah.
I breathe in these spores. The initial immune response is activated. Then to talk us through the secondary responses.
No, absolutely. So, I mean, this is, so all pathogens that we recognize they have antigens. That's what the immune system recognizes. And so we call the antigens on things that don't cause us harm but trigger these responses allergens. So that's one of these. So apologies if I slip into these kinds of terms.
That's good to clarify.
So the allergens are present, and then what happens is, there's a cascade of different immune cells coming, and they activate cells that secrete these certain secretory factors called cytokines, and it's cytokines that mediate a lot of the immune response. And it's these cytokines that cause all the features that you're associated with, like things like asthma or allergies. So they'll cause like your airway hypersensitivity, it makes you cough. All these cytokines are sort of triggering responses on epithelial cells, all the cells in our lungs, which will cause overproduction of mucus. So if you've got an asthmatic, they're much more likely to make mucus. They struggle to breathe because literally the immune response is causing the airways to shrink. And this is all caused by something that we're all seeing, and it's completely harmless to some of us, yet some people
have this exaggerated response. Yeah.
So there's this idea. So that's kind of trying to avoid all the jargon.
Would you agree that what we're seeing when this happens is essentially a pro-inflammatory response?
Yeah. So it's sort of what we would recur to as inappropriate. So it's or if I was going to be precise, so I should try to be hypersensitivity. So that's kind of so it's a type of a hypersensitive response. So autoimmunity, for example, is also a hypersensitivity response. Right? You're reacting against yourself, whereas hypersensitive in the context of allergy is that you're reacting against something that is actually harmless. Now, actually, fungus is kind of this interesting thing. It's not harmless because if you don't get rid of it, it can cause really serious disease. So if you're immunocompromised, the fungus can invade your tissue. So it's one of these sort of, as ever when we try come up with classifications, there's always these grey areas, right, where the things don't quite fit. So in the context of fungus, as what we think is going on is, as a healthy person is continually clearing this fungus regularly, because we're breathing it in all the time, for whatever reason, and that's what we're trying to understand what those signals are, it's triggering a response that can be inappropriate, and then that drives this pro-inflammatory response.
Gotcha.
Does that make sense?
Yeah.
And steroid treatment, so people who go on treatment for things, that's not curing, it's just dampening down this inflammation.
Totally, yeah. So we're treating the symptoms, not the root cause in this respect.
Correct.
What about direct impact of the mycotoxins themselves? So are the...
well, this is a different...
this is a different...
Yes, it's a different thing. So
okay.
No. So this is... Lots of people obviously are interested in this. So obviously fungus are commensals as well. So we breathe in fungus, but we also ingest fungus. If that makes... obviously... Everyone thinks about the negative side of fungus, but obviously without fungus, you couldn't make bread and things like this, right?
Yeah, it's great stuff.
So we have resident fungus in our gut. The fungus, to create these sort of mycotoxins, these are these sort of secondary metabolites. You really need to have the fungus sort of growing, and in our lungs, they're not in there long enough to sort of generate sort of toxins, so to speak. I think what people normally worry about is things like if you get sort of contamination of crops and things like that, and that can then lead to higher levels of these secondary metabolites, and then that is being linked to...
That's directly toxic.
Yeah. But I think in the context of your question of mold that we're breathing in, that's kind of a separate thing, if that makes sense. Now, of course, the complexity of this is that, obviously once... if you're immunosuppressed or some kind of impairment and the fungus is actively growing... So these fungus can, literally invade a lung if in the right conditions. Then, of course, those secondary toxins can also cause disease. So I think the mycotoxin side of things is more people are worried about ingesting food
with mycotoxin.
With mycotoxin in.
Yeah.
Really where mycotoxins, is when they're sort of, it's gone bad within storage.
I know it's a big issue within... certain crops, commodity crops, grain, wheat.
It's
coffee.
Because of the storage.
Yeah.
So it's not necessarily, it's not an issue at harvesting and stuff like that.
No.
It's more just when they store it, there's a risk of, because the spores are everywhere, that they grow and contaminate and spoil the crop and they don't realize.
Yeah, absolutely. Let's start hypothesizing about the susceptibility. I'm really intrigued by this because it is another difficult question to answer about what is it about someone's genetic makeup, environment, lifestyle that leads them to be more susceptible to the same patch of mold that is being, breathed in by other people around them.
Sure. Well, so I think there is certainly a genetic element, so again, there are, you meet people where, that they've got asthma, their mum had asthma, their grandma had asthma.
Right.
So there are certain genetic associations with you're more predisposed to getting asthma. Absolutely. But I think if you actually go to these studies and this is not fungal specific, I should stress at this point, this is more in the context of just asthma globally.
Yeah.
And asthma is a great example of really it's an umbrella term for probably lots of different conditions does that make sense? So you can have two different asthmatics, but they actually have quite different kinds causes of response, but the same symptoms. It's one of the inherent challenges of it. And so effectively in an asthma context, most, it's about 50% is thought to be genetic. And then the other half is environmental. And that's very hand wavy, but that's because it's not like the sort of genetic studies they've revealed some key factors, but there's no sort of smoking gun of this is the key thing that we could target, we could cure asthma. It's more complicated than that. Partly because this is a chronic condition and we're all exposed to different things in our environment all the time. And that's actually one of the major factors. Obviously, risk factors, if you're more sedentary, if you're overweight, if you're spending, a lot of time, if you're in environments where you're exposed to much higher levels, all of those things are risk factors. But there's also things like pollution as well. So and all these things I think are connected. So if you overlay incidents of hypersensitivity to pollution, I think you get a very good correlation. And also the other interesting thing and there's some things we don't completely understand, the rate of hypersensitivity of asthma is going up.
Yeah.
And why that is, I don't think people have great.
No.
There's loads of theories. For me, what makes most sense is that it's multifactorial, and I think diet clearly has an implication. If you're exercising more regularly, that clearly, if you're not exercising, and then of course, if your diet's worse and you're not exercising so much, then you're going to become more overweight. And we know that if you're overweight, your immune system changes as well. So all these, but also, how well are you sleeping? We already know, people have shown that, if you sleep poorly, that can impact your immune system. And so, and of course, we're all living busy, complicated lives. So trying to understand all these factors is really challenging. Yeah. And I think what I would propose, I guess, is we're trying to look at, what is that fungal side of the equation? How is that driving that? But you can't ignore the other factors. So again, people say, you could be in a household of people and only one person develops a response to fungi and the others don't. Why is that, right? And so that can be, genetics has a part to play in understanding that almost certainly, but all these other factors are probably contributing as well. So.
What I'm hearing is susceptibility is a mix of genetic predisposition, although we're largely focused on asthma, but in terms of if you have other illnesses, if your diet is poor, if your liver health is poor, if you're in a high environmental pollutant area where your body is essentially trying to detoxify as much as possible, and you add the added stress of mold exposure, you're more likely to have symptoms potentially.
Yeah, I think...
I mean, it's kind of hand-wavy.
It's very hand-wavy, and obviously we have no proof of that, but that's kind of that's sort of our thinking.
Let's talk a little bit more about the other conditions. I think anecdotally, you hear a lot of stories, particularly post-COVID, of chronic fatigue being associated with mold exposure. And, once people sort the mold out, that we'll talk about in a second.
Yeah, sure.
Again, anecdotally, their symptoms improve. Their, the brain fog, all the symptoms that we would associate with chronic fatigue, although that is a very broad sort of umbrella term for what I believe is a whole host of different conditions. So all these things do seem to add up for certain people. And I think mold is, again, as an underappreciated research field, and something that, as doctors, we don't really talk too much about mold other than outside the context of asthma or immunosuppressed patients. It's probably a blind spot.
Absolutely. So I should, and it's fantastic if people have recognized mold might be making it worse and they've corrected that. It's fantastic. That's really great to hear. I guess, again, from a scientific perspective, proving that, as you said, is really difficult. and the data's just not there to be able to give concrete advice. But I think it's, again, if all of us can reduce mold exposure in the home, that probably won't be a bad thing.
Yeah.
But somebody who's improved that, they could have changed other things in their life without even realizing, like that's the challenge, isn't it? As you know, with when you sort of people do interventions, it's really challenging to work out, well, is that the only thing you changed, or was there other things you changed in by doing that change? And I think, this idea of sort of the environment, what we breathe in and how that affects our health, I think we're only really sort of scratching the surface, or, tip of the iceberg, really, in understanding how what we breathe in the environment is impacting us more broadly in our health is, I think really a fascinating question.
Yeah.
But it's one of these things that you could talk. It's very difficult to give concrete sort of evidence, but it's things like, like people who have, I think I mentioned earlier, sort of, log burning stoves in their home, which people say, but then you're exposed to a huge amount of particulate. Yeah. So even if you've covered up the mold patch, but then you put a log burner in your home. So there's all these sort of does that make sense?
Yeah, I guess you can't standardize for your exposures, in
exactly.
the home. Whether you could be using an air freshener,
exactly,
you could be exposing yourself to a whole bunch of other household chemical products. Let's talk some strategy about reducing mold exposure, which I think you would agree is a pragmatic strategy for everyone. I would say.
Yeah.
So if we're trying to reduce our exposure, what should we do?
Well, the first thing is, for example, if there's a root cause of it, trying to fix that issue would be ideal. So, for example, if there's a damp patch and you've got a leaky roof, maybe try and fix, if you can. I know that's not always easy, but that's sort of one of the I know that sounds very basic, but really that is, if you can make your environment slightly less favorable, that's way better. And then I guess the other strategy is, I think we chatted earlier before about, trying to circulate air in the house. That's a great one as well, because they do sort of, if you've got windows open, that can create a circulation of airflow that can be helpful. Difficult, of course, in the winter months if you're trying to save and not have your heating bill too much. So one of those, that's part of it. Also, just trying to clean it really early on. So if you notice it building up, trying to remove it before it gets too bad, because then it makes it much harder to get rid of.
How do you remove it?
Just like with sort of cleaning products, there's a sort of no, it's just, you can, and also I guess stopping build up of water and condensation. That's another key thing, right? So
do you have to physically remove it, or I've heard if you use a chemical or a bleach, that's one of the worst things you could do, because it could break down the spore size and make it even more likely for you to breathe it in.
Again, it's one of those things that I don't think there's any evidence that I'm aware. It's possible that could be the case. I think it's just, again, it's like, but those, I think what's more of an issue is sometimes those products themselves can be quite harmful. In the first place, right? Yeah. And so what's worse, the chemicals or the mold in the first place? It's that sort of challenge. So I think I think if you can get rid of it before it's got really bad, that's sort of obviously one of the key things. Obviously, you might have to resort to things like that. But then if you do use it, maybe keep the windows open and don't go in that room for a little while to let all of that. Does that make sense?
So
I know this is sort of common sense sort of stuff.
No, but it's simple stuff. I mean, I think a lot of people, particularly in...
But I should stress, we all get, so for example, it's not like my wife laughs at me because she says, I go and talk about mold and then I come home and we have the same things. Yeah. We have 2 kids. So we are, they're a bit older than yours, but I know exactly what you're referring to. So again, we have the same challenges of how do you keep on top of it and trying to minimize it. So it's just that sort of, trying to make sure that you're keeping on top of it from a cleaning strategy. So for example, bathrooms are normally, classic place of where it stores up, but maybe sort of, trying to get rid of it more regularly rather than let it really build up and then try and remove it would be much more effective.
What's your opinion on dehumidifiers? to try and reduce?
So I get asked this a lot. I think it can absolutely help because it will reduce the moisture. But of course, it depends where the moisture is as well, right? So if the moisture's in the wall, but absolutely, it could help. Again, there's anecdotal evidence that some people say it does and other people say it hasn't helped at all. But the theory of it would be sound. But yeah, it could be one strategy. If you have a particular problem. I know when I was renting a long time ago, we put one in, it made no difference. So,
yeah.
So I think it's down to that sort of personal sort of experience.
Air purifiers.
Again, they absolutely might be able to help. But of course, if you go outside, you're going to be exposed. If you open the window, then potentially. So I don't know how, say if you had I don't know if those studies have really been done, that if you put it into a moldy room, if you said if there was a massive mold patch here and you put one over there, would it really reduce it? Would it be able to cope? I don't know.
Yeah.
So I think you'd have to check.
I wonder if you had a decent air purifier that reduced the particulate matter in your room, and you're working in an enclosed room for a long period of time, like working on your laptop or whatever, or even rooms that you spend a lot of time in, like your living room where you're watching TV, that kind of stuff. It kind of makes sense.
It would make sense. I guess the proof is in the pudding.
Yeah.
And so it's really, I'm not aware of people who've actually done studies on that.
Yeah.
But absolutely, in theory, there is some logic to it.
Yeah.
But I don't know. And again, it goes back to what we said right at the start, which is that for certain people, it probably wouldn't make any difference because they're probably got quite a high threshold.
Yeah.
And we don't really understand why that person would have a higher threshold than somebody else. But for somebody else, maybe it could help.
This has been great. I mean, like I appreciate the nuance and the fact that we're keeping it strictly around the evidence base, but there's enough, we've got room where we can talk about some hand wavy stuff as well. I think it's important because
it's my background as a scientist that I just can't help but
a lot of people are investing a lot of money and time and energy into removing mold from their home, but also thinking about it as the root cause of symptoms as well for people who are perhaps suffering with chronic fatigue or raised inflammation, or they're just trying to optimize their homes. And I think that personally, I think that's a pragmatic decision.
Yeah.
We've had mold in my home. I've got a young child, and so I'm constantly thinking about, just trying to optimize his environment as much as possible, looking at even electricity exposure, as well as like particulate matter and all the rest of it, so as well as maintaining his healthy diet. So I think it, we do get asked questions about mold quite a bit. So I'm glad that we've had a conversation with you about it. Epic. Well, thank you so much, Peter. That was an education for me, and I'm sure we're going to get loads more questions about mold as well. But we will direct them to your university email address.
well, yeah, absolutely.
No, it's all right. We won't do that. There'll be thousands of emails. Thank you. I really appreciate it, Peter. That was great. If you loved that episode, you will love the full library of podcasts from the Doctor's Kitchen Library. We talk about everything from inflammation, supplements, and food as medicine. Just like this episode right here. You can click it right now and check it out.